help also. So we are solving a system of equations by graphing. This is how we finished our last school year. And so we're going to start with, what is a system of equations? Well, it's two equations in our world. It can be 3, it can be 4, but thank goodness we don't have to do that. It's two equations in two variables. And they can be 3 variables, and again, hopefully we don't have to do that. So what we're going to say is, this is the definition for a system of equations. Two equations in two variables. They're going to work together. They're called a system of equations. Everybody has one of these, correct? Anybody get left out? Okay. Well, when we solve it by graphing, we really only estimate the solution. That's why when we solve it by graphing, we do a check problem. So to estimate the solution to a system of equations using a graph, where you're going to get your estimate, you're going to determine the point of what? What's that called? Intersection. The point of intersection. Where are those two lines meeting? And they're going to meet at what we call an ordered pair. It will have an x value and it will have a y value. So when we're solving for the two variables x and y, they're going to be combined together in an ordered pair. The good news is today when we are graphing, our equations are already going to be in slope-intercept form. So let's just put that over here. Let's just remind ourselves that what slope-intercept form looks like and why it's such a big deal. Slope-intercept form. What does slope-intercept form look like?
Not that way.
Trey?
When it's solved for y.
When it's solved for y.
When it says y equals.
When it says y equals, yeah. So y equals, what's the general form that we talk about? Isaac?
Y equals mx plus b.
Yeah, y equals mx plus b. When an equation is solved for y already, then we can say it's in slope-intercept form. Y equals mx plus b form. What does the m represent, you guys? M is slope. Let's remind ourselves of that. M equals slope. B is what? The y-intercept. These are important things for us to remember so we can be successful with graphing so that it can hopefully lead us then to the correct estimate to check to say, oh yes, this is the solution for that system. So we have our system, y equals 3x plus 1. Is that in slope-intercept form? Y equals 3x plus 1.
Yes, it is.
That is slope-intercept form? Okay. How about y equals negative x plus 5? Is that in slope-intercept form? Okay. So when we're going, we can just go right to work getting ready to graph them then. So here's our first one, y equals 3x plus 1. What's our slope?
3.
3, right there. So when we do 3, do you remember what we do on the graph for that? What do we do to graph with slope of 3? What do we do? Isaac? Oh, not to the right 3. What do we do? Let's go up 3. Mom says go up 3. And then go right, what number? 1. Or, remember we have another option. We can go down 3 and left 1. So we'll get this practice in again. And then the y-intercept, what's the y-intercept for this one? 1. In other words, we're going to start at 1 on the y-axis. Let's put that in to remind ourselves. Start at 1 on y-axis. That's what that tells us to do. Okay, so let's go ahead and do that then. Before we move on to the other equation, let's just get this one graphed. Right? Pardon? Yeah, they're coming. So start at 1 on the y-axis. Make yourself a point. And from that point, use your slope. We have 2 different ways to use our slope. to get more points. What's the minimum number of points I let you use? Remember that? 3. Unless you can't fit 3 on the graph. We use 3. So we're going to go from that point, we're going to go up 3 and over 1 to the right. Or we have the option of going back to our starting point and going down 3 and 1 to the left. Right, and that's what they're showing. Oh yeah, and we should put the negative signs there. Thank you, JC. Let's put negative signs. Let's go back up here to our slope where we're going down 3 and left 1. We're actually really making the rise negative and the run negative when we do that. Okay? So you are right, JC. We want to make those numbers negative. It would be 3 down and 1 left also. Okay, and then with your line, you're going to draw your straight line with what at both ends? Arrows at both ends showing that that line goes on indefinitely in both directions, okay? So, let's draw our line. Oh, I didn't do a very good job again. I'll practice again. Okay, back to here. Okay. Now we can move on to our other equation. Y equals negative x plus 1. What's our slope for this one, Josh? The slope is for y equals negative x plus 5. Yep, what's the slope for that one? Negative 1. Okay, I like that. It's negative 1. Well, negative 1 means then that I can do what? I can go 1, negative, we can do it negative 1 over positive 1, right? So we can go down 1 and right 1. Or our other option is instead of making the rise negative, we can make the run negative. So it can be positive 1 over negative 1. Then we would go up 1 and left 1. So notice when we grabbed our first line, it had a positive slope. And our line matches that. It has that kind of behavior. It is rising from left to right. This one, what kind of behavior should it have when we're done? It better be falling from left to right. Okay, so we're going to, what's our starting point for this one?
5.
5. Okay. Remember, if it's subtraction here, be really careful. We always do what? We change subtraction to add the opposite. So if that had been minus 5 instead of plus 5, we would have changed it to plus on negative 5. Then we would have started negative 5 instead of positive 5. So be careful, remember that rule. Change subtraction to add the opposite before you decide what your y-intercept is. Okay, so we are going to start at positive 5 here on the y-axis. We can use the go down 1, right 1. Can we use the go up 1, left 1? No, it's off the graph, so we'll just do it again. Because how many points do I say you have to have?
3.
3, unless the graph won't hold it. Well, this graph can hold. We can go down 1, right 1 again. And now we can draw our line through that one. And now we can estimate our solution. What do we estimate our solution to be? Anybody want to give us your estimate of the ordered pair solution is? Cameron?
2, positive 2, positive 4.
Okay, positive 2, positive 4. You all agree? In other words, they are intersecting at ordered pair 2 for the x value and 4 for the y value. Isaac?
I have to disagree. I would have to say 4 positive.
He thinks it's 4 positive 1. Okay, so you think it's this one.
Switch them.
Oh, and then Brighton says, no, switch those up. Okay, which one is it?
Middle. The bottom. Middle.
Here's what we do. Remember to name an ordered pair. We start at the origin, and we say, okay, it's right there, so it would be 1 to the right, and 4 up. It is this one right here. That's the one it is. So we're going to say that the solution is 1, 4. And I moved my thing, but just, okay. 1, 4 is our solution. We have to check it. We're gonna check it. Here's how we check it. We go back to our equations, we write them down. So we have y equals, what was our first one? 3x plus 1. And our other equation was y equals negative x plus 5. It has to check out in both of them. It has to make both of them true. And you don't get out of this, okay? So we're going to substitute in, excuse me, for my y, I'm going to substitute from our estimated solution. I'm going to put a 4 in. And for the x, I'm going to put a 1 in. And I'm not going to stop by just putting it in. I'm going to do some simplifying until I get it down to something that one side either matches the other or I say something's wrong. So 4 equals, that doesn't have any simplifying we can do on the left. What's 3 times 1? 3. And then 4, can't do anything with that. What's 3 plus 1? 4. Checks out in that one, but it has to check out in both of them. So now I go and do the same thing. I put a 4 in where the y is. I put that negative sign is not part of the x. That negative sign is not part of the x. I put a 1 in for the x. And I simplify. Simplifying is going to look like this. 4 can't be simplified. This can become, what's the opposite of 1? Remember, that's how we can read a negative sign. What's the opposite of 1? Negative 1. Four is 4. What's negative 1 plus 5? 4. Legitimately? It is, isn't it? Checks out. So we're going to say that the solution actually is ordered pair 1, negative 4. That's how we write it, as an ordered pair. 1, negative 4 is our solution. That's our solution. It is one of many ordered pairs that would make this be a solution. It's the only one. These two lines only cross each other in one spot, so it is the only ordered pair that satisfies the two equations together. It's the only one. It's the only answer I can accept for it. So any questions? Is it looking familiar?